recording over here and also share my screen. No? And yeah. Yeah, I hope the screen is visible. And let's get into the problem number 8 real fast. It's, yeah, can anyone go ahead and explain what the problem statement says? Let's have a healthy discussion, guys. See, I need a two-way discussion. If you guys, speak up and talk, it'll be very interactive as well. Correct? And it'll be good. So, someone take their initiative to start and explain problem number 8, which is batch goal problem. Anyone wants to go ahead and explain? I hope the screen is visible. Yeah, the screen is visible. Fine, no issues. I'll explain it myself.
I'll explain, Bhaiya. I'll explain.
Yeah, sure. Go ahead. Who is this?
Okay, so Kushwan. Kushwan.
Ushwan. Okay, cool. Just go ahead,
So
Kushwan.
we are given a number n, and we have to represent it as a sum of prime numbers, sum of some number of prime numbers, and we have to represent it in such a way that the prime numbers that we are using will be the in maximum number as possible.
Cool. So the count of the prime should be maximum, right?
Yes,
Count of the prime
correct.
should be maximum. So when
Yeah.
I say count of the prime should be maximum, so what does the first thing come in your mind? So when the count of the numbers, so here let's approach it. Count of the numbers is maximum, correct? And we know we have some kind of sum we have to reach. We have to reach some kind of sum, right? Say, let's say,
Yes.
yeah, let's say we have 10, correct? Let's forget about this prime. How would you represent 10 as maximum number of numbers? So, sum of maximum number of numbers.
by using the least value number.
What is the least value number which can add up to 10?
One plus
1,
one.
right? So when if you ignore 0, of course 0 won't be here. So if you see 1 plus 1 plus 1, if you do it 10 times, we'll get 10, right? So can this count of ones be maximum than, I mean, more than what they are right now? So we have 10, correct? We have 10 ones. Can it be more than 10?
No.
No, obviously no. Because this is the least value which we can, represent 10 as in like 1 plus 1 plus 1 plus 1 plus 1 plus 1. But the problem statement right now states that there is a given number n. We have to represent it as a sum of primes. And count of those numbers should be maximum. The same question, guys. The same question, but here the twist is the count. I mean, it's primes. So, what is the first thing you should come in your mind? That I should take the least prime, correct? What is the least prime here?
Two.
2 is the least prime, correct? Okay, so 2 we took. Now, we want to represent, let's say we want to represent 10, right? So, how would you write 10 in terms of maximum number of prime numbers? 2, 5 times, correct? Yeah. But what if I ask you represent 11 in the same manner? Can you represent 11?
Two, three.
You can't with only 2's, right?
Yeah.
Yeah. So it will be like 2. And then what is the next smallest prime? Which is 3, correct? 3. So let's forget about this 3. If you only have 2's, then the sum will be 10. But we need sum as 11. So what we can do, we can remove this 2 and add 3. Correct? So now, is there any other way to represent 11 better than this? Can we take another prime? Maybe 5. 5. It's not possible, right? If you add 5 plus 5, 10 again. 10 plus 1. 1 is not a prime. So it's not possible. The least number you have to take and sum it up. So that would be obviously 2, 2, 2, 2, and then a 3. Correct. I hope this is clear. So they asked us number of numbers, right? How would you calculate the number of numbers? So here in this case for 11 it is 1, 2, 3, 4, 5. 5 numbers, and this is the answer. So you would print like this: 5, 2, 2, 2, 2, 3. Correct. So can I say that any number n given, any number n, the number of numbers you can represent it, or
Number
the
of
number of
numbers you can
hello, yeah, number of primes you can represent in are nothing but n by 2, right? If it is 10, 10 by 2 primes it can be represented as like 5 primes. That is 2, 2, 2, 2, 2. Let's say 11. We saw 11. Again it's 5. This time around it is 2, 2, 2, 2, 3. So the count would be nothing but n by 2, and the numbers would be 2, 2, 2, 2, and the last number, check if the number is even. Okay, check if the number is even. So n is even, or n in this case is 11. So we'll have a 3. The last digit will be 3. If not, it will be a 2. So that is it. If any doubts, you can ask, and then we can proceed. If not,
Sir, in this we have to use the least numbers itself, smallest prime numbers.
yes, smallest
Few
prime
numbers.
numbers. So how
So
did I come with the conclusion that we have to use the smallest prime numbers? Because maximum possible number of primes should be in the representation, right? So here, this part, maximum number of primes should be in the representation. So when will the number of representations, or number of numbers will be maximum? When they are least, right? In case of
yes, sir.
11 or 10, we represent it as 1 plus 1 plus 1 plus 1, 1 plus 1 plus 1. But they said we have to represent it in prime. So we would take 2, 2, 2, 2. Right? Now you got it? Or do you have any other doubt?
No, sir, I got it.
Got it? Excellent.
Yeah.
So this is problem number 1. If anyone has any doubt, you can ask. Let's move on to the problem number B, where it is a little bit implementation heavy. I mean, it is a good problem to be honest, and 16 people were able to solve it. That's really good actually. So we'll not just read. Okay, we will have to read to the statement. Correct. I'll read it for you guys. So let me paste it over here, and let's take an example case. So problem number B. Make it smaller. Okay, so what does the problem statement say? Let's read it up. This time I'll read it on my own. So Valera is a little boy. Yesterday he got a huge math home task at school. Okay, so Valera didn't have enough time to properly learn English alphabet for his English lesson. Unfortunately, the English teacher decided to have a test on alphabet today. At the test, Valera got a square piece of a squared paper. So we know that it's a square piece. So just write it down: square piece, square piece. Okay. The length of the side equals to n. Okay, they gave the length of the square. So length of a side of a square. That is nothing but n. And each unit square contains some small letters of English alphabet. So what does it mean? Let's see. Okay, Valera needs to know if the letters written on the square piece of a paper form in the paper on the paper forms an X. So there's a square like this. There should some kind of X form on the paper with the letters. Okay, let's see what's the letters about. Valera's teacher thinks that the letters on the piece, or I mean, letter on the piece of paper forms an X if on both the diagonals of the square paper all the letters are same. So what are the diagonals of the square? It's this, right? So all the letters on the diagonal should be same. Okay, this is the one statement one. And then all other squares of the paper, They are not diagonals. They are talking about other, other characters which are there, other letters which are there. Okay. Contains the same letter that is different from the letters on the diagonal. It should be same from each other, but different from the diagonals. Okay. What does that mean? So let's take this example here. So it says we have n is equal to 5, correct? And then we have x, o, o. Okay, I'll do one thing. Just copy this and then paste it over here. Okay, so we have this test case, right? So what does it say? Let's see. Yeah, x. We have an x. We have o x o x o x x x. So first thing what we have to check, on the both diagonals of the square paper, all the letters are the same, right? Let's check the diagonals. This is the diagonal, right? This is the diagonal. We have x x x x x. So that is the same for first diagonal. Okay, and then second diagonal, which is from right to left, right? This diagonal right here, we have all the same. Okay, second diagonal also satisfies. Very good, that is also satisfying. And also, what's the next constraint they said? That all other squares of the paper, they're not on the diagonal, so they're not on the diagonal, so all other squares contains the same letter that is different from the letters on the diagonal. So it should contain the same letter, as well as it should be different from the x. In this case, it is the diagonal, first and second diagonal, whatever the characters were there, it should be different, right? So let's check. It is o. Okay, that's good. O, good. But there is an s here. So what does it mean? This s is breaking one of the rule, that all of the others should be the same letter. So hence you will print out no, because s is different from o. So therefore it doesn't make a valid x, because there was some other element which was not equal to the other diagonal. I hope this problem statement is clear. Correct? So what would your intuition be? How would you go ahead and solve this? Can anyone share their intuition who wasn't able to solve this problem?
Matrix.
Matrix. Very good. Very good. Matrix. One is matrix. Okay. So anyone wants to share their thought process on how they approached this problem but failed to solve? Don't be shy, guys. It's okay. We'll just figure it out. There's nothing to worry about. Okay. Yeah. Go ahead.
So for this, like the size of the two-dimensional array should be same, right? Like the rows and columns both.
Yeah. So rows and columns should be same. That is already given, right? It's a square.
Okay.
Yeah. So rows and columns should be same. That is already given in the question. So it's a square. We don't have to worry about some distorted square, like, I mean, a rectangle or some kind of other shape. It's a square given. So n rows is equal to n columns. That is clear. Correct? Okay.
Yeah. So then we need to input the string 5 times based on the number given.
So we have to input this string 5 times based on the number given. Perfect. So yeah, once you input that, so what you're gonna do is you're going to build a matrix out of those strings. Correct? That's what you mean, right?
Yeah.
So x o o. That case we are going to look at x, fine, and so on. All the elements. Okay. What's the next part? We build the matrix.
So, then we have to store each character.
We have to store each character. That is in this part, right? Where we are going to build a matrix. So wait, I have a doubt, guys. Do you have any doubts in how to, form a matrix out of the string? Like this string is given, right? Anyone has a doubt on how to form a matrix, or is it clear? Like when I say we're gonna form a matrix of n into n, wherein every element in that matrix represents the character at particular string. That is clear, right? Or is anyone having a doubt in there?
Anna, could you explain the code for this matrix once? Because I'm
Yeah,
not
sure,
sure.
sure. Cool. So, so let's build this matrix first. Okay. Then we can come back. Okay. Building the matrix first. Matrix. So first thing before building the matrix is you have to, create a matrix, right? That would be something, maybe let's say grid. The name of the matrix is grid is equal to new int. What will be the size of the matrix? So this is important for non-Python users. Python users, you can like form a matrix pretty easily. But what is the size of this grid or the matrix? It is nothing but n into n, correct? Because we have 5, right? 5 they gave. 5, if 5 is a side, then what will be the, how many columns and rows will be there? There will be 5 columns and 5 rows, right? That is pretty simple. And then what we have to do is we have to run a for loop. For we are running I from 1, that is, let's say 0 actually, to 5. So it will run for 0, 1, 2, 3, 4. Right? It will run n times. Okay. And each time what you have to do is nothing but you have to take in the string, input the string. Let's say the string is something like this, correct? Now you have inputted the string. Now for this string, you have to put it. So let's say this is the matrix, correct? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And also we'll have 1, 2, 3, 4, 5. Correct? We have 5 into 5 grid, right? Now, what we are going to do is we are going to iterate through that string now. You understand? We are going to iterate through that string. How would you do that? We'll run another for loop. This time j will run from 0 to same as 5 because there are n into n columns and rows, right? Now what would you do? What would you do is at this grid of I and j. So what I and j, you are going to put this character x. So that will be nothing but string, the particular string dot character at j. So what does that mean is the first iteration I will be 0, j will be 0, correct? And then grid of ij. So that is this position 0, comma 0. At this position, I am going to put string dot character at j. What is j now? 0. So I'm going to put the 0th character of the string over here, x. Right? Now, let's move forward. Now j will become 1. Now what will ij become? Ij will be becoming, what will it become? It will become 0, comma 1. So O will come here. Then j will become 2, 0, comma 2. O will come here. So this O, right? This O will come here. And then this row O will come here. That is how you do for every string. Do you get it? Is it clear?
Yeah,
Yeah? Good.
yeah.
Now that we formed a matrix, so we know that there is a matrix, correct? Now, what is the two things they are asking us? First of all, the diagonals should be having the same characters. So diagonal should have the same character. We saw it earlier. And the elements which are not at the diagonal, right? They should all be same and different from the diagonal. Correct? They should all be same in the sense. Here you see O, 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 O. They are all same, but this S is different. So hence it is not a valid, valid square or valid condition. So you're gonna output no. So the first task for you guys is to find how do I identify a diagonal in a matrix. Okay. So let's see. Let's write it down. Because the first thing we are going to do is check the diagonals if they are having the same elements. Correct. Now I'll write down a 3 into 3 matrix. Okay. 3 into 3 matrix. Okay. And I'll fill them with the positions. I'm not going to fill, I'm just going to write down the positions. This will be 0, comma 0. correct? This will be 0 comma 1, this will be 0 comma 2, and this will be 1 comma 0, this will be 1 comma 1, this will be 1 comma 2. Now this will be 2 comma 0, and this will be 2 comma 1, and this will be 2 comma 2. Okay, now the first thing is check right diagonal, check both diagonals. Okay, diagonals. Let's check this diagonal, right? This, this, and this now. So what do you observe here? Is there any observation I can make with the indices I and j saying that this is a diagonal? Can anyone answer?
I equals j.
Correct. Exactly. I equals to j. When I is equivalent to j, can I say this is the diagonal? Correct. Can I say this is the diagonal? Right. We can say that is a diagonal. Right. And the next part. Now we have to figure out this, right? This part right here. So, is there anything, any relation in I and j? So that I can say
I
that,
I
yeah,
plus j equals to
I plus j equals to this.
2. That is n minus 1.
Exactly. Excellent. So that is nothing but I plus j is equal to n minus 1. If you see here, 2 plus 0 is nothing but 2. 1 plus 1 is nothing but 2. 0 plus 2 is nothing but 2. That is nothing but the other diagonal, right? This diagonal. And the condition is I plus j is equal to n minus 1. So we found out this diagonal. We found out this diagonal. Correct? Now, can I say the rest of the elements are not the diagonals? It's obvious, right? So the rest of the elements are not the diagonals. So now let's get into our part 2, which is nothing but we have to check if each of these are diagonals. So that is nothing but, I mean, sorry, if each of the diagonal elements are equal. So what should I check here? 0 comma 0 should be equal to 1 comma 1 should be equal to 2 comma 2, that should be equal to 0 comma 2, that should be equal to 1 comma 1 again, and that should be equal to 2 comma 0. Correct? If this satisfies, then what will I say? That the condition 1 satisfies. That is nothing but the diagonal condition satisfies. Right? Now, what is the second part of the problem? It says that whatever is not the diagonal also should be equal. Correct? So typically I would say that 0 comma 1 equals to 1 comma 2 equals to 1 comma 0 equals to 2 comma 1. Correct?
So,
So yeah, just tell me.
sir, can you explain the logic behind the second diagram? First one I understood.
Yeah. Second diagonal. This one, huh?
Yeah.
Okay, sure. So here, so if you see here, I'll draw it again. It is 0 comma 0. Correct? I mean, okay, the better thing would be just erase this, waste less time. So here, the first diagonal is I is equal to j, that is clear. The second part is, so here I plus j is equal to n minus 1. N is nothing but size of the square. Okay, so that is nothing but here, what is the I? That is 2. 2 plus 0 is equal to 2, right? 2 is nothing but 2 is equal to 3 minus 1. Since it is a 3 into 3 matrix, 2 is nothing but 3 minus 1. That is nothing but 2 is equal to 2. So this is satisfying. And again, 1, and this is also one of the part of the diagonal, right? This diagonal, correct? So 1
Yes.
and 1. I plus j is nothing but 1 plus 1 is equal to 3 minus 1. Again, it is 2 is equal to 2. Here also, 2 plus 0 is equal to 2. That is nothing but n minus 1. 3 minus 1. 2 is equal to 2. Got it? Let's take another square for your understanding, let's take 2 into 2, 0 comma 0 is here, and we'll have 0 comma 1 here, 1 comma 0 here, 1 comma 1. It is now n 2 into 2. So n is equal to 2. This diagonal, we know that I is equal to j. Correct? 0 is equal to 0, 1 is equal to 1. Perfect. Now this diagonal, we know that I plus j should be less than or is equal to n minus 1. Correct? So let's check. 1 plus 0 is equal to 2 minus 1. Is it satisfying? Yes. 0 plus 1 is equal to n minus 1. 2 minus 1 satisfies. 1 is equal to 1. 2 is equal to 1 is equal to 1 here also. Here also we satisfied. Here also we satisfied. So you might ask, how did I come up with it? It is pure observation. First, the thing is, when you get some kind of pattern over here for this, there must exist another pattern which would say that there is another, where I can say that the other diagonal also might have some pattern. So what I'll do is simply if I don't know the formula or this, what I'll do, I'll just try for 2 into 2, I'll try for 3 into 3, I'll try for 4 into 4. If it works for all of these, it will work for n into n as well. So that's how you come up with some kind of, logic you want. So did you understand now?
Yes, sir.
Yeah, cool. Now where was I? So yeah. Yeah, now we have to find all of the other elements that should be equal, right? Other elements which are not diagonal should be equal, right? So in this case, it will be 0, comma 1, 1, comma 2, 0, comma 1, comma 0, and 2, comma 1, right? So guys, can I say that? So now I just wrote it just like I had written it. I have written it like the values I have written it. But when you have to put it in code, how would you put? Right? I've just written the coordinates now. It is not always 3 into 3. It could be 4 into 4. It could be 5 into 5. So how would I put it in code now? So the first thing I would do is, for the first case, now logically think in this way. Suppose I have to check if all elements in the diagonals are same. So can I say that 0, comma 0 will be equivalent to 0, comma 1? So 0, comma 0 will be equivalent to 0, comma 1, right? And 0, comma 0 will be equivalent to 0, comma 2. So now I'll take some kind of integer saying diagonal. Let's say diagonal is equal to grid of 0, comma 0. Okay, why am I taking this? Because now when I iterate, what do I mean by iterate? When I go through all of the elements in this array, the first thing what we did, we checked if the diagonals had the same element. So what I will write the condition is inside the for loops. So this will be the first for loop. This will be the second for loop. So first one will go from I to n. That is nothing but 0 to n minus 1. Okay. And the second j will go from again the same 0 to n minus 1. Correct. Now part 1 of the solution. What did we see? We saw part 1. Let me write it like this. Part 1, diagonals, right? If, okay, what is the code now? I mean, what we have to do? We have to check if the diagonals are equal. So since we are going through all of the elements, this element, this element, this element, so eventually we will find some diagonal elements as well. So I'll just simply write if grid of, not grid. What is the condition for diagonal? If I is equal to j, or why am I writing an or? Can anyone say why am I writing an or?
So the second diagonal.
Yes, so that I can write the second condition, which is nothing but n minus 1. So can I say that whenever I find the diagonal element, right, it should be equal to our variable diagonal. Is it clear? Is this part clear? It should be equal to our variable diagonal. What is diagonal? It is grid of 0, comma 0. So what I'm saying is when we iterate through a grid, whenever we find something, right, some diagonal element, it should be equal to what? 0 comma 0 ultimately, because all the diagonal elements should be the same. So I will say if it is a diagonal, and then inside this, what I will write is if current element, that is grid of I and j, is not equal to diagonal. Diagonal is nothing but the variable. So I will say print no. Why is this? Can anyone explain why is this? Or did you understand what is happening here? If you did not, you just tell me. I'll explain you again. Did everyone understand?
Anna,
Yeah?
in this, if we print inside the loops, then multiple times it will get print, right?
Excellent. So what will we use for that? Can we use some kind of variable? Oops. So what we can do is, so the logic you understood, right? We can handle that. We can handle that. But
Yes.
did you understand the logic, right? So we'll print no, and we'll have some kind of variable flag, okay? And then we'll set it to false. Okay. Initially flag will be true. Here we will say flag, okay, is equal to flag, flag is equal to true. Correct. Now what we will do is we'll just set it as false. I'll come to it later. How will you handle this false? Okay. Now this is the diagonal part. Diagonal part is clear. Now what is the non-diagonal? Non-diagonal is nothing but it is this, right? This is a non-diagonal. This is a non-diagonal. This is a non-diagonal. I mean, so this is a diagonal. This is a non-diagonal. This is a non-diagonal. So I would also take another variable int non-diagonal, non-diagonal, which will be equal to grid of what can we take? Does anyone have any idea? What can we take as a non-diagonal element? Can we take this element here? Awesome. That's awesome. 0 and 1. We can take the non-diagonal element as 0 and 1. Correct? Now what we will do is, this is the case when diagonal is there. So part 2 is non-diagonal. When? I'll write it here. So when non-diagonal is there, what will I write? For this will be the closing. Else, so if it is not a diagonal, it is a non-diagonal. Else, again I would check if grade of, that is nothing but the current element, grade of ij is not equal to what? Non-diagonal.
equal to non
Non-diagonal, right? So now what will I do? I'll print.
do. I'll print.
Yeah, anyone wants to speak?
Anyone wants to speak?
Okay. So I'll print a no. I'll set this flag to false. Okay, I'll set it to false. Oops, not the double equal to. I'll set it to false. Okay, so now what is before the loop starts, I will check here. So part 1 diagonal is done, right? So I'll erase it. So I will check if flag is equal to false, break it. Here also I'll check if flag is equal to false, I'll break it. So what does it do? It will only print this no once. And this also once. Understood? Understood the logic, how we went on? Is it clear?
Understood how we went. Is it clear?
Okay, why can't I hear myself? Hello? Yeah, did you guys understand? Is everyone clear? Rahul. Yeah.
Rahul. Yeah.
I can't hear you, Rahul. All I can hear is myself.
Here is myself.
When you unmute, I can hear like me talking. You can type it in the chat if you are not clear. I think this was a very big problem. Yeah, clear. Okay, cool. Okay, that is what you had to say. Huh? Fine, thank you. Anyone has any doubt? Pravalika, you have any doubt, or shall we move on?
No, no, it's clear.
You got the logic right. Fine, that's good.
Yes.
Cool. Now the problem number C. So from here, I think it will be easy because this is the only problem I think where you found difficult, and these problems are like fairly easy compared to B. B is like implementation heavy. So now let's do C. Hmm, okay, let's read it out. Pari has a friend who loves palindrome numbers. Okay, but what is the palindrome? The first part. Palindrome is nothing but it is the same from front and back. If I write this from the front, it will be ABA. If I write this from the back, it will also be ABA. So there is a palindrome. Okay, what is a palindrome number? 101 is a palindrome number. 1001 is a palindrome number. 222 is a palindrome number. So these are all the palindrome numbers, right? Okay. Now, what does it say? A palindrome number is a number that reads the same forward and backward. For example, this is okay. Pari is trying to solve, Pari is trying to love them too, okay? But only very special and gifted people can understand the beauty behind palindrome numbers. Pari loves integers with even length. That is, okay, even length. That is, they gave an example, right? So it is a 2-digit number or a 6-digit number or a 4-digit number. That is the even length. Correct? Now, so she tries to see a lot of big palindrome numbers with even length. So maybe she could see something in them. Okay, so she saw something in them. Now, Pari asks you to write a program that gets a huge number n from the input and tells what in the nth even length positive palindrome numbers. I mean, see, it is asking simply asking what is basically Pari is giving us n some value and we have to find that values palindrome number. For example, 1 is 11. So the first palindrome number, which is nothing but it's 11, right? Is there any palindromic number before this which is also even? Okay, don't forget the fact that it is even length. And it's a palindrome, correct? So the input was 1 here and we got an output 1 1. And let's say the input was 2. What is the second palindrome number? Could 12 be a second palindrome number? No, right? The second palindrome number would be 22. Can you say like any other number before this is a palindrome? From 11 to 21? 11, 12, 13, 14, 15. No, it is not a palindrome. The first number after 11, which is a palindrome, is 22. And also it is the second palindrome number according to our, this thing, according to our condition, where n is a even length. So n is a even length. 22 is a even length. It's a 2 length, right? So what is the question asking us? We have to directly print the nth. That is nothing but n. They can give anything. Nth palindromic number. Is it clear? Is it clear, guys?
Yes, sir.
Cool. Now, what is the constraints? So the first thing you have to see is we can solve this mathematically, right? Maths, we can apply maths and solve it. Very good. We can find the palindromic numbers and solve it. But if you see the constraints, what does it say? N can be from anything to 10 to 1 to 10 to the power 10 to the power 6. 10 to the power 10 to the power 6. Imagine how big is this? Can it fit in an integer? It won't. Can it fit in a long? It won't. So it will exceed this limits. Basically, it will exceed integer and it will exceed long. So what is an integer range? Integer range is nothing but 10 to the power 9. Long range is nothing but 10 to the power 18, approximately, not equivalent, 10 to the power 18. So where does this 10 to the power 10 to the power 6 lie? It is very, 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 very huge, right? It's very, very, very huge. It is like a, you know, in some kind of universal number. I mean, not a universal number, but it's a very big number. Infinite. It's infinite. Long, long double. Okay. Yeah, I see. You can, long, long double can do it. But can it do this big? I mean, it's a huge number. It can hold a huge number. Can it hold this number? Okay. Also, even if it holds, can you perform palindromic operations and get it to some nth palindromic number? So what is the time constraint? We should also see the time constraint. It is 1 second, right? So in 1 second, can we find the nth palindromic number where n could be 10 to the power 10 to the power 6? Where in one operation there are, in 1 second there will be 10 to the power 9. So that is 1 billion operations, right? So 10 to the power 10 to the power 6 is very, 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 very larger than 10 to the power 9. Correct? So what I would, say here is, what I would conclude here is that I should not go in the math direction, because performing operations will get too large. The number itself is very large. The number is very large. Also, the operations which we are going to perform is also too large. There are many operations. 10 to the power 9 operations won't be enough, right? So now we have to think it in some other way. Okay, we have to now see, this is the beauty of the problem. So now we know that it will not be, we won't be able to solve with the math. So is there any way we can solve it? This is where pen and paper comes in hand. So always remember, when you're not, always remember, this is the basic rule actually. Pen and paper is must. Without pen and paper, you cannot solve problems. Okay, unless you are like, highest IQ guy, you cannot solve problems. So you will require pen and paper for every problem. But specifically for this problem, now that math doesn't work, now let's try out some kind of pattern. Because see, is there any other way we can find, when there is no math applicable here, there is no other way for us to guess the number or find the number without some kind of pattern. So always remember, when something is too large and seems impossible to do, just try out the patterns. Just try out the patterns which they give. Okay. For instance, let's see. Okay, I am just solving the problem. Say I don't know the problem, or I don't know how to solve the problem. So what I'll do is, first I'll write the first palindromic number. That is nothing but 1 1. The second palindromic number 2 2. Third palindromic number 3 3, and so on. Let me write down all of the palindromic numbers. Okay, let me give some space. 2, that is 2 2, 3 3 3, 4 4 4, 5 5 5, 6 66, seventh palindromic number 77. Okay, I'm writing down blindly, but do you guys realize that the first palindromic number is 11, the second one is 22, and the third palindromic number would be 33, and the fourth palindromic number would be 44? You realize that fact, right? Because anything in between won't become a palindrome. Say 21 or say 30, say 31. It won't become a palindrome, correct? So I would find out the palindromes and I would write it down. Okay. Now I will go back to 8, 88. 9 is 99. Correct. Can 10 have a palindrome? So what will be the 10th palindrome? My question is. So can it be something like 101? Because see, the next palindrome after 99 is 101. Can it be 101? Guys, I'm asking you.
It can be 101, but for this question, it cannot be.
Exactly. It can be 101. But here we specifically they asked us it should be of even length. Correct. So 101 won't be our palindrome. So what will our 10th palindrome be? Something after the longest third digit number, that is 999, because this cannot form. We need an even length. What is 99 after 999? It is 1000. Correct. Is 1000 a palindrome? No. Is 1001 a palindrome? Yes, it is a palindrome. So what I would say is, I'll erase this. The 10th palindrome number, the 10th palindromic number is 1001. Now my task for you guys is to find 11th palindromic number. What would it be? The 11th palindromic number. So let's check. Can it be 1002? No. Can it be 1009? No. Can it be 1100? No. Can it be 1111? Yes. Is there any other number? It can be 1014 or 1105. No. 1106. No. It cannot be, right? So the next palindromic number I found out that is nothing but 1111, right? So for 12, similarly, the next palindromic number, when you find it manually, it will be 1221. For 13, it will be 1331. Just find it on your own. Okay. But this is the pattern 1441. Do you guys see a pattern here? Do you guys notice something?
Yes, Anna.
What is the pattern you're noticing?
The number we are giving is added as a reverse of the number.
So the number which we are getting plus the reverse of this number, which is 01, is nothing but our answer. You can test it out. You can test it out on anything. But here, if I mathematically prove, it is a big proof. Okay. I will not. But for this kind of problem, all you have to do is write down all of the numbers from start, and you will eventually realize that, okay, wait, there is a pattern over here. So can I apply this pattern? So what you will do, you will check for the examples. Okay, so my pattern was 10 will become 1001. So 10 plus 01, that is nothing but 1001. Is it correct? Yes, it is right. So will it work for 1? 1 plus reverse of 1, that is nothing but 1. So here it is string, guys. Don't get confused. It's not a number. It is nothing but 1 1. Is that our answer? Yes. So there we go. We got a pattern here. The pattern says that whatever the n is given, n plus reverse of n is our answer. Let's say n is 14, the answer will be 1441. N is 25, the answer will be 2552. So the code will be very simple. First, take in the string. String is equal to something. So input the string. And then what you do is nothing but string, some other string is nothing but, let's say this is S, let's say this is P, S plus reverse of S is this answer. So how simple is the answer? It's just one line code. But all you have to do is you have to observe it. Observe each and everything. Okay. Is everyone clear here? Cool? Clear? You can type it in the chat or yeah. Go ahead.
It's clear.
Clear, right? Good, good. That's cool. Now let's move on to the next problem, which is where we have the least amount of people, solving this problem. So what is it? Yeah, Vanya and lanterns. Cool. Let me paste it here. This is the question, guys. Yeah. So what does the question explain? Vanya walks late at night along a straight street of length n. Okay. So whatever input they give, we are going to write it down. Street is of length L, correct? Lit by n lanterns. So we have some lanterns and we have n of them, correct? Now consider the coordinate system with the beginning of the street corresponding to the point 0. Street is at point 0. It is starting at 0. Very good. And then it end point is at the point L. So we have L, right? That is nothing but the L. That is the end point of the street. Then we have ith lantern is at the point AI. So some ith lantern is at AI. Okay, let's figure out what is that. The lantern lights all points of the street that are at the distance at the most of d from it. Okay, so there is a lantern. Let's say this is the lantern. I don't know how to draw it. Okay, this is a lantern. So it can, you know, send light or it can lit up to distance d. Correct? It can lit till the distance d. So why am I taking the both directions? Because we are considering x-axis, right? So it will be giving light till here, this point and this point. So what does that mean? I'll write it down in simpler language. Say let's say the lantern is at point 5. Okay, there's a lantern here. And then let's say the d is equal to 2. So it can light up to 7 over here, and then it can light up to 3 over here. So that is D, right? 2, 2. So one lantern can light up to left side, the distance D, and the right side till the distance D. Correct? That is the lantern's, property. Okay. Vanya wonders what is the minimum light radius D should be the lanterns. I'm sorry. What is the minimum light radius D should be? The lanterns have to light the whole street. Okay, the English is not good, but it is saying that what is the minimum distance this D should be so that the whole street is lighted up. So, what does that mean? From 0 to L, all the points should be lighted up. All the coordinates, meaning everything should be lighted up. Okay. Now let's see input. It is two integers n and l. We already know l is the street length and n is the number of lanterns. Correct? The number of lanterns and the length of the street respectively. Perfect. The next line contains n integer ai. So we are coming to the ai part. Multiple lanterns can be located at the same point. Okay, fine. The lanterns may be located at the end of the street as well. So they are saying that ai is nothing but the position of the lantern in the coordinate axis. That is nothing but from 0 to L. It is some kind of position in it between. Let's understand with an example here. Correct? Let's take 7 and 15. So n is 15, n is 7, L is 15. So what will the coordinate axis be from to? What will be the length of the coordinate axis, guys? Can anyone answer?
8.
Say, yeah, hello?
Is it 8?
Sorry?
No, is it 8 from 7 to 15?
No. So what is n? N is the
Yes,
number of bulbs. Let's say bulbs we have. L is the end point of the street. Correct? So L is nothing but the end point of the street. They said it is the length of the street. Length of the street, which is nothing but the end point of the street because we are starting from 0 and then ending at L. They did mention, right? See here, they mentioned that the beginning of the street corresponds to point 0, right? In the coordinate system, they also mentioned that. So the street always begins at point 0. And now where will it end? If the length of the street is 15, 15 is the length. Where will it end, guys? What is this value here? It is 15, right? It ends at the 15th point. Did you understand this or you have any doubts? Guys, response please. Clear, right? Hello. Okay, cool, cool. Thank you, Deepak. So this will be nothing but it will be 15. And now what are these now? 15, 5. So they gave like this, right? So that's nothing but 15, 5, 3, 7, 9, 14, and 0. They said that this is the position of those bulbs. Position. So what does that mean? Okay, let's draw it out. So this is the point number 0. And let's draw a line. This is the hardest part. Yeah. So this will be 15. And in the coordinate system, this will be 1, this will be 2, this will be 3, this will be 4, this will be 5, this will be 6, this will be 7, this will be 8, this will be 9, this will be 10, this will be 11, and then we'll get it till 15, 11, 12, 13, 14, and 15. Cool. This is the coordinate system, right? This is how our x axis works, right? 15. Now, what are they saying is at these positions, we have bulbs. So let's draw bulbs. At position 15, we have a bulb. Okay. At position 5, we also have a bulb. At position 3, we also have a bulb. Okay. At position 7, we also have a bulb. At position 9, we also have a bulb. At position 14, we have a bulb. At position 0, we have a bulb. These are the bulbs, the position of the bulbs. Now, what are they asking us to find? The minimum light radius D, which is needed to light the whole street. Okay. The answer will be considered correct if absolute or relative error doesn't exceed 10 to the power 9. Okay. Error they have given, but 10 to the power 9 is fine. Okay, we'll come back to this error. I didn't see this actually, but it will work if you use double as well. But yeah, now if you see here, these are the bulbs. Now what are they asking? The radius of D, which is needed to cover the whole street. So D, if I say D is equal to 15, so this bulb can light up the whole street, right? Technically, this is D. Correct. It can light up the whole street. So now what our task is to do is minimize this B. Minimize the distance of the light. So D should be minimized. I can also say that if D is 7.5 or let's say 7, D is 7, this will cover from here to here. It will light the street. And from 7, it will light till 14. This is the next part. And from 14, it will also light till some point, which is 21, but also it will light 15. So all of this will cover the street. So the street is lit, correct? The street is lit. But 7 is not our answer. We have to minimize this 7 such that it can light the whole street. Got it? Now, how would you approach it? Any ideas? These are the bulbs. These are the bulbs. And this is the distance between each bulb, right? These are the distance between each bulbs. So we have to minimize this D. What is this D? Light length. Light length. Okay. Till where the bulb can emit the light till. We have to minimize this such that the whole street is lit. This is the whole street. It should be lit. There should be no point such that there is no light. For example, if I take E is equal to 2, D is equal to 1. Let's take D is equal to 1. From 0, it will go till 1. This length. This length. And from 0, it will go till 2. The light from this bulb. Now, do you see? This is empty. There is no light in this part. Correct? So, D is equal to 1 is not the answer. We need the whole street to be lit. Correct? So, Deepak, can you say some idea for this? If you have any, can you share your idea?
Um,
Hmm. It's okay if you're not able to do, but did you understand till here? Hello, Deepak. Did you understand till here?
yes, Anna.
Okay. So fine. You don't
Anna,
have any.
how
Yeah.
like
Yes, Anna.
Yeah. Yeah.
if there are if there are two lanterns and we'll find the lanterns which are most far apart and half their distance between them, so it's like that will be the minimum thing.
Very good. That is one point. Okay. So Pravalika says here that okay. Before going to Pravalika's point, let's ask everyone if they understood because this is very crucial. This part. Correct. You guys understood, right? Yeah, so nobody is speaking, so I'm assuming that you guys understood. So Pravalika says that okay, someone just a minute. Think okay, fine. No text, right? Yeah, so Pravalika says that find the distance, okay, between the uh, furthest lanterns. So, for example, here we have lantern at 0. So we have a bulb at 0. We also have a bulb at 3. So what will the distance be? It will be 3 minus 0, that is 3. Between those two bulbs. Here, what will it be? 5 minus 2. 2 is the distance. Here, what will it be? It is again 2. Here, what will it be? It is again 2. 9 minus 7. So distance between the lanterns. Perfect. So what will it be? 5. Correct. And then what will it be? 1. Now we can, now she says that find the distance, take the maximum distance, which in our case is 5. 5 is max distance, right? Half it. Pravalika, can you explain why do we have to half it?
Because it's in a radius, so 9 will be like if we half it, it will be 2.5. 9 will contribute 2.5, and the lantern at 14 will contribute 2.5. So the whole thing will be covered. And since everything else is smaller than 5, they'll be covering each other. The light
Excellent.
will be covering each other.
Yes. So what she says is when we divide this by 2, that means that this bulb is also contributing as well as this bulb, this lantern is also contributing. So, so 5 by 2, 2.5, right? This will contribute 2.5 and this will also contribute 2.5. So that will make a distance of 5. So these will contribute like equally and hence 2.5 will also work for all other lanterns. Say why? Because the distance is anyways less than 5. So here the distance is 3. So light 0 will contribute till 2.5. 2.5. And this light will contribute till 0.5, right? But the street is lit, right? This part as this part and this part and this part. So the street is lit. So this is a right approach, right answer as well, right answer. We have to take the maximum distance between max distance between two lanterns and half it. Simple, because there will be adjacent lanterns, and we can find the what do you say? We can find the the distance. Correct. Max by 2 will be our answer. But do you think max by 2 will always work? This is where you have to think. You have to think, okay, so now I said that it won't work, right? But you should have that question. You should question yourself, will it always work? Because what if there is a situation like this? We have 1, we have 0, right? From 0 to let's say 5, correct? We have bulb at 0, lantern, I mean, whatever. Okay, we have it at 0, we have a bulb, and it again, let me write down the coordinates first. So this will be 1, this will be 2, this will be 3, this will be 4, right? So we have a bulb at 0, and also let's say we have a bulb at 1. We only have 2 bulbs here, 2 lanterns. Now what will our answer be according to what we found out before? The max distance between lanterns. In this case, since there are only 2 lanterns, the max distance will be 1. And answer will be nothing but 1 by 2. That is nothing but 0.5. But if it is 0.5, if the answer is 0.5, will the whole street get lit? Because from here it is 0.5. Okay, from here it is 0.5. Okay, this part is lit. And from here it is 1.5. This part is lit. What about the rest? Is it lit? No, it is not lit. So then what do you have to do? Prabalika, do you get it? Now what do you have to do?
Yeah.
Now what can we do, Prabalika?
Not sure.
Okay, not sure, right? Fine. So now we have those 2 bulbs here. 1, 2, 2, 3, 4, 5. Can I say, or can I assume, I should not assume basically, can I say that the max distance can also be from here to here? So from the last part, which is a L, minus the last lantern, this can also come in the max. So what I am saying is, if this distance, let's say this is P, if this distance is greater than max, then max will become P. Do you get this? The max will become P. Because say max was initially 3.5. So it would go till here, 2.5. It would go till 4.5. But this part is not covered, right? So we would check if L minus the last lantern, which is this part, P, if it is greater than the max, which in our case it is. So what we'll do, we'll make the max as P. Similarly, yeah, go ahead. Tell me. Somebody unmuted, right? Hello. Cool. Fine. So this is the part. Similarly, what if the lanterns are from, let's say 5 again, 3, 4, 5. Lanterns are from here and here. This both. Now L minus the last lantern will be nothing but 0. Because the last lantern is at 5. 5 minus 5 would give you 0. And the max would give you 1 by 2. So 4 plus 5 by 2. 1 by 2. The distance by 2. So that is nothing but 0.5. But can this cover the whole street? No. So the next thing will be nothing but the first lantern minus 0. That will be nothing but first lantern. You should check if it is greater than max. Then the max will change to first lantern. Got it?
Yeah.
Yeah. That is how we solve this problem. And also see, talking about error, right? So error is nothing but 10 to the power minus 9. So what does that error mean? 10 to the power minus 9. Basically, it says that uh, if you do 2.5 by, I mean, sorry, 5 by 2, what is the answer you're getting? 2.50000000. So error to the power 10 to the power 9 means 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 places after the point. So what was the question? 9 places after the point. What did they say? Considered correct if absolute error or relative error doesn't exceed 10 to the power 9. That means they are saying that it is only considered till 10 to the power minus 9. That means only till 9 elements. Okay, so this will be the point. They are saying that it will consider correct. It is correct if absolute or relative error doesn't exceed this. So when you get your answer say it is 4.999999999. So the error will be nothing but 10 to the power minus 9. If you minus this. Just learn about the error, guys. But this is the basic idea. Then what it says is this will be corrected. I mean, this will be considered as correct answer. 2.499999 will be considered as correct answer because when we subtract it, it will be less than 10 to the power minus 9. We'll add another 9 here. Yeah. So that is the error part. Okay. Just check the error. For this question, you don't need error. I solved it without error. I didn't even read there was an error. So you can just solve it normally as well. But this is a very important part to learn. Just learn about errors because in binary search you will have problems of decimals, finding the appropriate decimal or approximate decimal. So then we will have some kind of factor as error. Just learn it. Okay, the next problem, the last one. So we have 10 minutes. That will be, I think, enough for this. Okay, by the way, you'll write the code for this, right? You can write it. Correct. I'll leave it to you guys to write the code for this. I'll share the codes later on, but you guys can write the codes. The next problem, also I'll just discuss the solution. You can write the codes on your own because it's not I mean, it is not that easy, but still you can try. If not, I'll just give you the codes anyway. Fruits. So fruits. Now the fruits. What does the problem statement say? The spring is coming. It means that a lot of fruits appear on the counters. One sunny day, little boy Valera decided to go shopping. He made a list of M fruits. Okay, we have M fruits. Fine. Fruits. And if Valera wants to buy more than one fruit of some kind, he includes it into several items, some kind of several items. Okay, some kind of several items are there. Okay. When he came to the fruit stall of Ashot, some kind of name, he saw that the seller didn't distribute price tags to the goods. Okay. So he's telling that the price tags are not on the goods basically, but put all the price tags on the counters. So we have some kind of items, our items, and price tags over here separately. These are the price tags. Correct. They are separately placed on the counter. Later, A shot. Our guy's name is A shot, right? Okay. Later, A shot will attach every price tag to some kind of fruits. So he has the price tag ready. He is attaching it to some kind of fruit. Okay. And Valera will be able to count the total price of the fruits from his list. He will stick the price tags and then he'll count the total price. Simple as that. Now, yeah, but Valera wants to know now what can be the smallest total price, okay, in case of the most lucky for him distribution of the tax. So, what can be the least amount of money he has to pay such that he buys all the fruits, correct? And then what is the largest as well? We have to find what can be the highest number of or highest price he has to pay to get the fruits. For example, let's not read this. Okay, this is the problem statement. Okay, input is nothing but we have 5 and 3. 5 is nothing but, okay, we will have to read, I'm sorry. 5 and n. N and m are nothing but the number of price tags. N is the number of price tags, and n is the price tags, right? He also said earlier. So there are n price tags, m fruits, correct? And then this part is nothing but the price tags. These are the price tags: 4, 2, 1, 10, 5. These are the price tags. And what are these? These are the fruits. Fruits, right? Fruits are nothing but he bought apple, he bought an orange, he bought a mango. Correct. Now he has to output the minimum cost and the maximum cost. So in this case, guys, what can be the minimum cost? B. So now we have the price tags. He can attach these price tags to one of the fruits in any order, right? He can attach them. So how would you get the minimum cost? Can anyone answer? If anyone is listening.
You can sort the cost and take it off.
It was not really clear, but I heard that we can sort it and take it. Okay, very good.
You can
So,
sort the entire thing and take the first few number of elements, like the number of fruits is 3 minutes for 3.
exactly, perfect. So, we are going to sort this first. Sort the price tags based on what price. So, 1 will come here, 2 will come here, 4 will come here, 5 will come here, 10 will come here. Now, these are sorted in ascending order. All the price tags are in ascending order. Now, what all fruits do we have? We have 3 fruits: apple, orange, and mango. So, what we can say is for apple, we'll stick on price tag number 1, that is 1 rupee. Let's say 1 rupee was the cost of apple, and then orange will be 2 rupees for orange, and then for mango, it will be 4 rupees, 4 rupees for mango. So, what will the minimum cost? Can it be less than this? Let's say we did not take 1, we attached this 5 to the apple. So, apple would cost 5 then it would increase the cost, right? So, of course, the cost should be minimum, but 1 second. The cost should be minimum then, right? So, then the apple cost will be 1 rupee itself. So, the minimum cost will be nothing but this 7 rupees. Similarly, what will be the maximum cost? Assign this 10 to this mango, assign this 5 to this orange, assign this 4 to the apple. So then what will happen? 7. So maximum will be nothing but, let's write it here. So the maximum will be nothing but apple will cost 10 rupees, and then orange will cost 5 rupees, and then mango will cost 4 rupees. So the maximum cost will be 10 plus 5 plus 4, 19 rupees. Seems simple. Good. This is the answer. Okay. So let's the same thing. Let's try it for test case number 2. Okay. Now I'll be quick because I hope you understood. Everyone understood, right? Cool. So we have 6 price tags. That is nothing but 3, 5, 1, 6, 8, 1. So we will sort it first. We saw that earlier. 1, 1, 3, 5, 6, 8. We sorted it. Now we have to assign each fruit to the price tag. Is there a 1? Yeah, there's a 1. Price tag. Correct? Now let's assign peach to 1 rupee. Okay, let's assign, so our cost will be nothing but 1 plus grapefruit will be 1 rupee again. Grapefruit will be 1 rupee plus banana will be 3 rupees, rupees 3 plus orange will be 5. This orange will be 5. Another orange will be 6. So now what the total will be? 1 plus 1, 2 plus 3, 5. 5 plus 5, 10. 10 plus 6, 16 rupees. We are saying that this is the minimum. But is this correct? They said that minimum is 11. This is definitely not right. So then how would you assign? So there is a, it is failing here. That part is failing here. Correct? Now the what I would say is, also I think I missed out something. When I assigned orange to 5, it means orange, I mean 5 rupees is applicable to both the oranges. Okay. I'm sorry. It's not 6 rupees. It is 5 5. Okay. I've missed it out. Okay. So orange will be 5. So now what I can say is, since I'm buying two oranges, okay, I will try to give this orange the minimum cost so that so that this oranges, right, can come in the minimum cost. I'll write it and explain it. So rupees 1 is the orange and we have two oranges versus what we did last time. We assigned orange to some kind of 5. Then what will happen? 5 into 2 will become more expensive, 10. So the strategy would be more the oranges, I mean, more the same kind of fruit assigning to the least price. Why is that? Why is that even working? Because, see, when we assign one price tag to one fruit, it is applicable for both the fruits. So then you don't have to go forward with it. You don't have to go forward with it. So therefore, what I would say is, since I'm buying two oranges, I will assign the least value to the oranges. And then I will continue with the bananas. Banana will be 3. So that will be nothing but rupees 3 plus grapefruit will be 5. Rupees 5 plus peach would be, no, banana would be 1. I'm sorry. Banana would be 1, right? Because see, this one was taken by orange. Banana will be 1 plus 1 rupee plus 3 rupee plus 5 rupee. That will make it to 11. So what is the strategy here? Since we have two oranges, the count of two oranges, and it values the same price tag. Price tag is not changing. In the other cases, price tag is changing, right? So I would assign the minimum cost to the most repeating fruits, basically. In the case of maximum, I will assign this 8 to oranges because two oranges into the maximum will give me the maximum. Can I get 16 in any other case with two fruits? No, I cannot get 16 because if I take banana as 8 and peach as 6, it will be 8 plus 6, that is 14. Still less than 16, right? So, more the number of fruits, I will assign it to the maximum slash minimum element. Is this clear? I hope I explained it properly. Is this clear, guys?
Yes.
Yes, sir.
Okay, perfect. So how do you go about and solve this problem? So okay, let's take a small example again. Let's take price tags as 1, 2, 3, 4, 5, 6. We have orange, we have orange, we have orange, we have grapes, and we have grapes, and also we have let's say peach. Okay, these are the price tags. These are the fruits. So now this one for the minimum case, okay, minimum case, What would you assign this orange as?
1.
1. Correct? Because 1
1.
into 3 will be minimum. What will you assign this grapes? 2
2.
plus 2 into 2. 2 grapes are there, right? Peach will be 3. 3 into 1. That is
Yes.
peach. This will be the minimum. For the maximum, what will it be? Orange will be assigned to 6.
6.
Grape will be assigned to 5. Peach will be assigned to 4. Now you get the idea? So the thing is, now you got the idea. How would you implement this? So I have a question for you guys. Do you want to implement it on your own? I will give you hints on how to do it. I won't directly tell you how to implement this. Or do you want me to say the complete implementation? It's up to you. Whatever you say, I'll do. Do you want to write the implement? What do you mean by implement? It's like code. Do you want to write the code on your own? Or do you want me to write the whole code and explain it? If not, I'll give you hints here. Jay, can you say? Jayadev, do you want hints or?
I think maybe we can have hints. I think into right.
Sorry, I couldn't hear you properly. Tell me.
I think I can try this one initially.
Okay, I'll give you hints. You'll try it on your own. Okay. Deepak, what do you say? Deepak, Pravalika, Jatin.
Yes, sir. I'll try on my own.
We can try.
Just hint.
Fine. So the hints would be nothing but. So if you don't know, you have to go learn the topics. So first, uh, hints, right? So we saw that we need the frequency, correct? We need the frequency, right? We need the frequency of each fruit. So either use hash map to calculate the frequencies. Hash map or frequency array. For now, don't worry about this. Implement it with a hash map. Okay. You found the frequencies now. After that, you have to sort the frequencies. Okay. Then, once you're done with these both, right, this is the whole problem. Once what you have to do? The frequency into, then you have some frequencies, say 3, 2, 1, 1, like this. These frequency, when you sort, it will become 1, 1, 2, 3. Now, once you get these frequencies, now whatever the price tag is there, price tags, let's say 3, 4, 5. This is sorted, right? We already saw. Now you have to, okay, let me write it like this. The problem is simple. Now you have to implement it. This will get your coding skills very high. This is a very good problem to, learn implementation. Now, first, what you have to do, you have to multiply this with this, this with this. Wait. Not like this. This with this. Okay. This with this. This with this. This with this. For minimum case. For the maximum, it is opposite. This with this. This with this. This with this. 5. And then this with 1. You have to multiply or not multiply, basically sum everything, and then minimum you will have, maximum you will have. Same method. This is the method we discussed till now. The only thing you have to do is implement the frequencies, sort the frequencies, and then tada, you have the problem. So this is a 1200 rated problem. That's a very good problem rating to be solved. Okay, you just try it on your own, guys. If you have any doubts, you can message me. I'll just clear it out for you. Is this clear? I hope the session was good, productive, and I hope we discussed it in depth today. Too much depth, actually. Is it okay, guys? Or you have any queries?
Yes, sir.
You understood? Cool then. I think if you did understand, then you were free to leave, guys. Thank you for joining the session. And yeah, keep solving the questions, get better. Bye.
Sir,
Yeah, Jatin, tell me.
today was my first session, sir.
Okay. What is your code forces handle?
That is Jatin Rajiv.
Jatin Rajiv. Okay. So how many did you solve?
So actually today I didn't solve any problem. I
No
couldn't solve it.
issues. No issues. But did you understood, right? What are the problems?
Yeah, like up till now, except for the lantern problem, rest all I understood.
Okay. So where was your doubt in lantern problem?